Algebra Chapter 1, Lesson 5, and we want to look at how we can use the distributive property to help us do what we call factoring. Now, because using the distributive property takes a number or a value that's outside and distributes it to each one of the terms on the inside, those final answers, those final terms have that factor, that number that's on the outside now, as a factor of the final answer. And remember, a factor is just a number that we use to multiply together. Well, if we know we can multiply a number times another number and get an answer or a product, we should be able to go backwards and take out one of the factors and create a multiplication problem. Okay, so that's kind of what factoring is. Let's take a look at some examples, and maybe that will help clear things up. If we look at the term 3x plus 3y, you'll notice, hopefully, that both of these numbers have a common factor. In other words, the number 3 here and the number 3 here have a common factor of 3, meaning 3 divides evenly into both of those. So because 3 divides evenly into both of those, I can do the distributive property in reverse. Now remember, when we did the distributive property, we took the number outside and multiplied it by each term in the expression. Well, what undoes, or what's the kind of the reverse of multiplication? It's division. So once I find the common factor, I'm going to put that outside, and I'm going to divide each one of these terms by that number. So if I divide 3x, or just the x we don't really need to worry about, it's going to be left over. The 3 divided by 3 is a 1, which leaves me as 1 times x, or just x. And the y term is also the same. So if I divide this by 3, that leaves me with just x. If I divide this term by 3, that leaves me with just y. And so I now have the expression 3 times the quantity x plus y. So rather than taking this 3 and distributing it in, I'm doing the reverse. I'm taking the 3 and dividing it out. And so now I rewrite the expression like this. And I can double check this by just distributing the 3 back in and seeing if I end up with the same value. Okay, so the distributive property in reverse will divide each term by the same number. The distributive property, we multiply each term in the parentheses by the same number. Okay, now sometimes they're easy to see like that. You can see the 3 in both of those, and sometimes they're not so easy. You get a little sneak peek there. In here, I'm looking for a number that divides evenly into each one of these numbers. All right. Now, it's not so obvious here because they all aren't the same number. However, it's somewhat obvious because if I look at the first number here, well, that's divisible by 7, 14 is divisible by 7, and 21 is divisible by 7. So I can do the distributive property in reverse by dividing each one of these numbers by the number 7. So I'm going to put the 7 on the outside and then go through and divide each one of these numbers by 7, and then what's left over remains in the parentheses. So the 7 divided by 7 is 1. That leaves me 1y, or just y. The 14 divided by 7 is 2. The 21 divided by 7 is 3, and then I leave the z as well. So with the letters, they're going to be left in there for right now. So we're really just dealing with the numbers. So we're just dividing each one of these numbers by a common factor, a number that divides into each one of these. Now, important note here, you want to use the greatest common factor, in other words, the largest number that divides evenly into these. Because if you get down to here and there's another number now that divides evenly into each one of these terms, then you have to take that one out as well in order to have the simplified answer. So look for the greatest common factor. All right, one more type of problem that we want to look at, and that's where, whoop, that's not that page. Hopefully it's on this page, yes. It's where maybe there's a number that divides into some of the terms, but not all of them. Now, when you're looking at using the distributive property in reverse, the numbers or the terms that are left inside the parentheses have to have had a common number to all of them. Let me go back here quickly, somewhat quickly, hopefully. Let's reverse this. Notice that each term inside the parentheses that I ended up with had a common factor of 7. If I go back to this page here, each term that I end up with here, this x and the y that I end up with at the end, had a common factor of 3. So these numbers or terms that end up in the parentheses at the end must have this number in common. If not, you can't factor them. In other words, if we take a look at this example that I have on this page here, there is not a number that divides evenly into all three of these numbers. There's not a number that divides into 14 and 3, other than the number 1, but that wouldn't change anything. However, we can factor just the ones that do have a common factor. In other words, if I look at the first two, I notice they both have a 14. Well, let's just factor those two and leave this other one alone. It doesn't have a common factor, but it doesn't mean we can't do that with these two. So what I can do is factor the first two terms only. I can divide each of those by 14. So the 14x divided by 14 leaves me 1x. The 14z divided by 14 leaves me 1z. Those were the only terms that have this in common, so those are the only terms then that have the parentheses around them. And then I leave the 3y out here by itself. I didn't do anything to it, so I have to keep it so it stays there. So every term inside the parentheses has to have this number outside as a common factor, because it's the distributive property in reverse, and when you distribute, everybody gets a piece. When we distributed it in, every term inside got a piece. So if we're going out, every term inside has to take something out. This term didn't get anything taken out, so it doesn't get to be in the group in the parentheses. Now, this method that I just showed you is called factoring by grouping, and we'll use those quite a bit in the future, but it's a good time to introduce that now. So that's factoring, which is essentially the distributive property in the reverse. If you think you've got it, you can go ahead and stop the video. I'm going to go ahead and do 6 examples after this, so you can watch some of those examples if you want to help you out, or you can just go ahead and tackle the assignment for factoring. So let's do a few examples. You can watch as many as you need. I'm going to do all 6 of these. As we look at the first one here, we have 9x plus 27, and we were looking for something, a number that will divide evenly into the 9 and the 27, something that's common. And we want the biggest one that's in common. We could go with 3, but there's a larger number that they both are divisible by, and that's the number 9. So we're going to factor out the 9. So we're going to factor out this 9, and so what I want to do is divide each of these terms then by the 9, and what's left over stays inside. So if I divide this by 9, I put it over here, we can do some reducing like we did before. That reduces to a 1. We have 1 times x is x. And then we can do 27 divided by 9, which is 3. So this would be the factored form of this. And we could double check by distributing and mentally and making sure we get the same answer. Okay? So that's factoring, looking for the common factor, the largest common factor that will divide, or the largest number that will divide evenly into each of these. Looking over here at 18a plus 24b, we're looking for a number that divides evenly. 2 would work, but let's see if there's something larger than that. 3 would work. Let's see, 4, 5, 6 will work. I think that's about as big as we're going to get, is a 6. So we can factor out a 6 because both of these are divisible by 6. So I'm going to factor out 6. So 6 is going to be on the outside. So I'm going to divide this by 6, or reduce this. So that's 3. 18 divided by 6 is 3. So that leaves me 3a. And if I divide this by 6, 24 divided by 6 is 4, and I have the b still, so that would be 4b. So this would be the factored form of this expression. And again, you can see it's quite easy. We just need to find a greatest common factor, and that's probably the most difficult part when you get some higher or larger numbers. All right, if we look at this one over here, we have 3 terms. So again, we have 2 options here. We want to look and see if we have a term for all 3 that we can divide by, because we would like to factor all 3. But if not, we can go back and maybe 2 of them can factor, and we can do it that way. Well, as I look here, I see that 5 is the smallest number here. 5 will go into 20, and 5 will also go into 35. So 5 is going to be my greatest common factor. So 5 is going to be on the outside of the parentheses, and then I want to divide each of these by 5. 5 divided by 5 is 1. If I divide this by 5, that leaves me 4, and then that's 4x. And if I divide this by 5, that's a 7, and so that leaves me 7y. Okay? So this would be the factored form of this expression, with 5 being the greatest common factor. Okay? Let's do this next one over here. Okay, over here we have 3 terms, and again, we want to look for a common factor of all 3. And it's a good idea to kind of take the smallest number there is in all 3 and see if that number goes into all of them. If it does, that's going to be the largest common factor because there aren't any factors bigger than that number. So that's a good place to start. So 9 goes into 27, 9 also goes into 18, so 9 is going to be my greatest common factor. So we'll use 9 to divide each of these. So 9 divided by 9 is 1, and 1 times r is r. And we'll divide this by 9. 9 goes into 27 3 times. That leaves me 3s. And then 9 goes into 18 2 times, and so we have 2. And so this would be the factored form of this expression. All right, let's take a look at a couple more. Here, again, I'm going to go with the smallest number here and see if that divides evenly into the other ones. If it does, that's my greatest common factor. 7 does go into 63 9 times, and 7 does go into 14, so 7 is going to be my greatest common factor. So 7 is going to be on the outside, and then, well, I wrote that too close, can't do that. So we're going to divide each of these terms then by 7. 7 goes into 14 2 times, that leaves me 2c. 7 goes into 63 9 times, that leaves me 9d. And 7 divided by 7 is 1, and so we have 1 here. Okay, so distributive property in reverse, that's factoring. All right, let's do one more. And again, some rather large numbers, but again, we're going to look at the largest or the smallest number and see if that divides evenly into the other terms, because then that will be my greatest common factor. 11 does go into 44, and 11 does go into 121, so 11 is going to be my greatest common factor, so that's what I'm going to factor out. So 11 divided by 11 is 1. 1 times x, that's in the identity, that's 1, or x, excuse me. 44 divided by 11 is 4, so that leaves me 4y. And 121 divided by 11 is 11. And so this would be the factored form of this expression. Okay? So factoring or distributive property in reverse, we're looking for the greatest common factor that each term is divisible by. We put that out on the outside, and then we divide each term, and then what's left ends up in the parentheses, because now if I would go back and distribute this, I would end up back where we started, and we can always double check that if needed.